All right. Hi, everybody. Welcome to the H2Os Phase 2 webinar. We have limited time today, so I think we'll just go ahead and jump in. And then just as people trickle in, it should be pretty obvious, and hopefully, and this will be recorded too, so people can always revisit it at a different time. So just to give you a brief overview of what we'll be covering today, we'll go into the background of the H2Os prize, give some context there, just cover the prize phases and awards, and then just cover the submission package and scoring criteria. And with that, I will hand it over to you, Jenny, and the rest of the prize team to kick us off.
Great, thanks so much, Brittany. So just to make the best use of everybody's time here, did want to share that this prize is supported by the Department of Energy's Water Power Technologies Office. The primary goal of WPTO is to enable R&D within emerging technologies in marine energy and next generation hydro and pump storage. Within hydropower, the Hydro Wires initiative, which is really designed to understand, enable, and improve hydropower's contribution to the grid, is the primary subgroup that is supporting this prize here. So all of our goals within this prize are related to that initiative and what we're hoping that you guys will achieve as our competitors. Next slide. This prize is specifically designed to support the renewable transition within the United States and help us to apply expertise from both within the hydropower industry as well as other related industries in AI, machine learning, and data science, and making sure that we can really leverage some of the information that you've all developed within your own areas of expertise to this particular industry as well. Our goal with the prize is to make sure that we are advancing the representation of hydropower within the power system, and we're offering, over the course of the 3 phases, $75,000 in cash prizes to those that are able to most successfully contribute to furthering these goals. And I'll hand it over to Clayton.
Thanks, Jenny. Yeah, so most of the content that we're going to present here today is, or a good chunk of it is a repeat of the Phase 1 webinar. And since we're short on time and really want to focus on the updates that are relevant for Phase 2, I will refer interested folks to go watch the Phase 1 webinar where we get into some of the background and structural details a bit more. And as always, please refer to the rules document and the other relevant materials on the registration package on the Topcoder site. But in generally, why is this competition important? We're interested in getting better coordination between hydropower operators and power systems. And so we're trying to incentivize scheduling approaches that maximize energy production capabilities without violating water management requirements. And so we're really interested in getting those to enable future energy deployments like renewable deployments and the benefits that could come with better coordination between the 2 entities. We're focusing on the same objectives in the Phase 2 that we did in Phase 1, but really looking at maximizing the performance of hydropower management, maximizing the benefits of hydropower generation, and then looking for solutions that are scalable, novel, something that hasn't necessarily been done before, and could be applied to other applications in the hydropower industry. So something beyond just the energy management of these systems, but something new as well. So we are working with a very similar structure for the water system operations, where we will represent the water system with physical constraints, operational, or in some cases soft constraints, and essentially are looking for competitors to submit a schedule of releases that respect the water management constraints, and whether those are environmental or flooding constraints that are sort of operational, or they are physical constraints that are like the mass balance constraints on a reservoir. They get scored differently, and we'll get into some of those details in a minute. But again, they're very similar to the first phase. Similarly, on the power system side, we're looking for a the water release schedule that participates in the power system operations, much like an electricity market, that the reservoir operations will be submitted to the power system, and the rest of the system will be scheduled in accordance with those reservoir releases and the power production that could be generated from those releases. In the power system, we'll be respecting unit level constraints like minimum up and down times, system level constraints like power balance, and then transmission constraints like not overloading each line, and ultimately we'll be trying to minimize the total system operation cost in the power system. And then that problem, as described in the rules document, will be used to evaluate the power system benefit scores. And ultimately, we are really looking for submissions, water release schedules, that avoid any penalties from violating water balance and management constraints, as well as maximize the performance of the hydropower fleet in the power system scheduling problems. And so ultimately, we think that this is the crux of the coordination problem between water managers and power system schedulers, and good submissions should be able to do both. But in some cases, there are conditions that are challenging to avoid, and we hope to highlight those a little bit more in this phase. For the competition itself, we're asking for, or we provide a set of data. In this case, we've updated the data for phase 2 to include a little bit more detail on the power side, some new things on the water side, so we'll take a look at that. And each phase of this challenge, we're in phase 2 now, will increase the complexity of the problems by maybe creating larger system sizes, maybe longer time horizons, and different sets of rules. In this case, we've really pushed on the different sets of rules and expanded the system size just a little bit. Then with that input data, the candidate, the competitor should prepare a submission, which is in the form of a water release schedule of every hydropower reservoir in question. So in this case, there are 4 reservoirs, and create the submission release schedule in the CSV per the format defined in the rules document, and submit that to the top coder platform, and it will be quantitatively scored in real time on the platform. At the end of the competition window, we are also asking for the same set of submissions with the technical narrative, the summary side, and any software that was used to create the release schedules. And the same set of rules or guidelines apply to each of those, and we'll review those in just a moment. Again, this is phase 2 with a $15,000 prize purse. We're closing, it's underway now. The platform is open. We'll be closing it's a 6-week competition window. So I forget the exact date, but in August, we'll close the competition and announce winners in September prior to the opening of phase 3. The platform for this competition is the Top Coder platform. If you haven't already, register for the competition, which is open now. Registration allows you access to the competition package that includes the data sets and the rules documents and all the other materials needed to compete. And then you can submit your submissions live in the platform, see how you did, improve upon that during the competition window. And then prior to the close of the competition, you also need to make sure that you submit the technical narrative and remaining technical narrative software and the summary slide, so that you can be eligible for the final evaluation and the final score. Just again, this is all review, but one more review that these are the things that we need. The only elements that are scored are the technical narrative and the reservoir release schedule. The reservoir release schedule is a quantitatively scored on the top coder platform. So that's a live updated. You'll get a score in a matter of minutes after your submission. And then the technical narrative is reviewed by a body of experts after the competition window has closed. Otherwise, the software and summary slide are not actually evaluated in the score, but are requested for completeness. The total scoring criteria, you can see the full breakdown in the rules document, but it's broken down to roughly 80% or 60 points for the hydropower quantitative evaluation, 60 points for the power system quantitative benefits, and then 30% for the technical narrative, the qualitative review that we perform after the fact, for a total of 150 points that go to your final score. The evaluation platform, same as last time. The reservoir release schedule is really the only thing that gets evaluated by the platform, and it is used in this way where we submit it to a water system simulation that checks for the feasibility of the releases in terms of, is there water available to actually make those releases, calculates the power production that would be manifest from those water releases, and really it goes in two ways. So first, the hydropower management performance is calculated to see if there are operational constraints violated by the release schedule, and that gets included in the quantitative score, as well as the hydropower production potential is calculated and is passed to a power system simulation as a hydropower production availability, sort of an upper bound on production at any time period. And then the power system simulation will accept those availabilities or not in an economic dispatch simulation problem that then goes into generating the hydropower generation benefits. The hydropower generation benefits and the hydropower management performance scores get combined to create the total quantitative score. On the hydropower generation benefits, on the power system evaluation side, where we break it down into two things. There's the economic benefit and the environmental benefit. The economic benefit is essentially the total hydropower generation multiplied by the electricity prices cleared by the power system problem. In this case, there are two changes to this scoring from the first phase that I want to highlight. First, in the second phase, we have included transmission network components and their limitations. So the locational marginal prices, or the LMP, may not be singular anymore. So in the previous phase, it was a single node problem, and so in the second phase, there's potentially multiple locations in the LMP price profile. So be aware of that. And then second, the other change is that when normalizing when calculating the largest possible power system benefits, down here in the bottom right, the largest possible power system benefits previously were calculated by the most expensive generation cost and its max output for the entire time period. And now we've actually run an economic dispatch without hydropower included in the problem to calculate the highest possible power system benefits. And so that's a little bit different from the previous one, but should provide a better normalization of the score. Those changes are highlighted in the updated rules document included in the competition platform. I wanted to highlight them here. On the water system side, we have a similar set of, nothing has changed on the water systems side. We break it down into two categories where there's physical constraint violations, which really are binary. You either respect the laws of physics and get a full score for the physical constraint, or you get a 0 score for this component and don't achieve mass balance. And then on the water management violation, there's a little bit more nuance, and the constraints for environmental or flooding constraints are included as soft constraints with a penalty associated with them. So there's some sometimes very significant penalties for violating these constraints, but in some cases it may be required to violate them to achieve a feasible schedule. And then again, it's scaled by a normalization factor that's detailed in the rules document. I want to highlight that we will also, again, require a technical narrative, and the narrative has the same set of qualitative criteria that will be evaluated against. Two things to note. First, the technical narrative does need to reflect the approach used for the phase 2 competition. So if you've competed in phase 1 and you're updating your approach for phase 2, will require a technical narrative that reflects any changes you've made in that approach for phase 2. And so that's important. And then the second thing, based on reviewing the phase 1 technical narratives, I want to reiterate that it is important to address each of the criteria laid out in the bullets laid out in the rules document and here, especially addressing the scalability and the adaptability of the approach to other aspects of hydropower management or this problem in general, as well as the diversity, equity, and inclusion objectives, and really want to remind people to address how diversity, equity, and inclusion could be incorporated or is reflected in their solution approaches, or how their solution approaches can impact diversity, equity, and inclusion. So just as in phase 1, we require the release schedule submission to be in this format. In this case, there's a new column. So there's a fourth column here called reservoir release, input release, reservoir 4 input release, because we have 4 reservoirs now. So, but otherwise it's a comma separated value file that gets submitted to the top coder platform with this format, including the range column with the datetime format. And with that, I will hand it over to Abby to do a quick review of the water system description on this phase 2 dataset.
Thanks, Clayton. Yeah, so we'll just really briefly go over the specifics of the phase 2 problem and how it's a little bit different from phase 1. So as you can see here, there's a network diagram that kind of shows how the system is set up with respect to where the reservoirs are located and where the operational constraints are in the system. And from the phase 1 problem, we have now included those operational constraints, which are part of the score, and all of that's outlined in the rules document, how we score those, but that's a new part of the challenge this time. So we have 4 cascading reservoirs and 3 operational constraints. As you can see here, at the top, reservoir 1 and reservoir 4 are parallel to each other, and they each have their own headwater inflows. Below reservoir 4, so the outflows from reservoir 4, both, if there's releases and or spill, those are subject to a minimum flow constraint. So, you need to have a certain amount of water in the river at that point. And then reservoir 4 and reservoir 1, those outflows come together at a confluence, and below that confluence is a flooding threshold. Below that flooding threshold, we have reservoir 2, which is essentially a run-of-river reservoir. There is a little bit of storage you can manage. Below reservoir 2, there is an intermediate local inflow. And below where that local inflow comes in, there is a demand that removes water from the river. That can be considered a consumptive use. It does not return to the river system at any point in the simulation. And then at the bottom of the system is reservoir 3. Reservoirs 1, 4, and 3 are pretty large storage reservoirs. So you'll have to manage that storage throughout the duration of the simulation. And then reservoirs 1, 2, and 3 are considered off-channel reservoirs, and reservoir 4 is considered an on-channel reservoir. And that has implications for how you may model spill. I don't want to get into all of the details on that, but please see the rules document and the phase 2 dataset description for the specifics on how to consider your spill in that calculation. Next slide. So just to review those operational constraints, for this phase, all those operational constraints are the same for every single time step. They're constant. In future, in phase 3, we might make those dynamic, so time dependent, but these are constant. So every time step has the same requirement. And like Clayton mentioned before, these are soft constraints. So they may be violated, and the violations are penalized based on the severity of the violation, but it may not be possible to meet all of these at every single time step. So just something to keep in mind. Next slide. And then just to conclude, the data set format is very similar to phase 1, only now there's new components for those operational constraints, and the reservoirs now have a reservoir type parameter which defines them as on channel or off channel. So hopefully nothing looks too new here, but that's it for the water side.
Thanks, Abby. On the power side, we've done a couple updates on the system from last time. It's mostly the same system, but we have added a representation of the transmission network. Of course, we've added the representation of the 4 hydropower facilities that to reflect the updates on the water side. We've also, instead of a single bus system, we now have a 5-bus system with 6 transmission components. A couple of them are transformers, but then the rest of them are transmission lines. And then otherwise, the 5 thermal generators and the loads remain this, I believe, the same as the phase 1 competition. I will note that with the inclusion of the transmission components, we have updated the rules document to reflect the change in the formulation of the power problem, because now with transmission components, we have to represent power flow through the network with a linearized DC power flow, just similar to any market clearing or economic dispatch problem in the power industry. And so that is included now in the rules document and in the power system problem formulation. Otherwise, other than the inclusion of the new transmission components and the updated connections of the reservoirs, there's been no change to the data set format. It's all the same on the power side. And then similarly with the output files, we are including the same set of output files from the phase 1. So you can use these to understand the details of how your scores were calculated and potentially improve your scores with this feedback that should be a live feedback from the top coder. And that is what we have for today. And I think we have roughly 5 minutes for questions if anybody has anything they need to have us clarify.
Well, thanks for the presentation. I have a question about your power system data. I was checking the dataset and noticed there is no base power provided for the power system. And since like the line data are presented in per unit. So I think we are going to need the base power for calculations.
You will need the base power. I apologize for that, and we will update. That was an oversight on our part. We'll update the base power. It is 100 MVA, so we'll use that.
Okay, thank you.
But we'll provide that. We'll update the data set to include that in the meta info at the top of the JSON. Thanks for the feedback. Sorry for that.
Will there be multiple LMPs in the output file?
There will be multiple LMPs in the output file. In the summary lmp.csv.
There's another question in the chat, Clayton. Can you expand on the change in pricing by removing the hydropower cost?
Yes, so it is clarified in the rules document. Again, this is just the normalization factor. So previously we had calculated the denominator of the power system economic benefit normalization by using the total the max capacity of all the hydropower facilities multiplied times the highest marginal cost of the generators. So we found the single highest marginal cost of any generator and just said, what's the full capacity of the hydropower generators times that marginal cost for price for every time period of the horizon. And that created a very large denominator and therefore gave very little spread in economic benefit score. So to improve on that and tighten the bound on that denominator, we ran an economic dispatch without considering any of the hydropower generators to create a price profile from which we could multiply to the maximum capacity of the hydropower generators. So that would create creates a much tighter and smaller denominator on that problem and creates more interesting scores. Does that answer the question? I hope. Okay. All right, with that, I think that we have closed out. Again, please feel free we try to be quite responsive on the Top Coder forums. So if you do have additional questions, please feel free to post questions there. Otherwise, good luck and thank you for joining.
Thanks, everyone.